Welcome, everyone. Today, we're going to dive into a really powerful calculus technique that is absolutely essential for anyone going into business: integration by substitution. Now, I know what you might be thinking, but this isn't just abstract math. This is a practical tool for turning complex, real-world cost models into smart, profitable business decisions.
So let's start with a classic business problem. Imagine you're a manager on the factory floor. You've got data telling you the exact cost to produce just one more item. That's what we call the marginal cost. But the board of directors, they're not asking about the next item. They want to know the bottom line. What's the total cost going to be for a full production run of the first 500 units? So how do you get from the cost of one to the cost of all of them? Well, this is exactly where our standard simple integration methods start to fall a little short.
And this is what we call the manager's dilemma. It's so much more than a textbook problem, you know? This is a real-world challenge that directly impacts a company's profitability, how it decides to allocate its budget, and its strategic plans for future growth. Getting this right is critical.
Okay, so here's a pretty realistic-looking marginal cost function. In the real world, business costs are rarely simple straight lines. They're often what we call composite functions, where one function is essentially nested inside of another. I like to think of it like a set of Russian nesting dolls. In our case, the x squared plus 50 is the inner doll, and that squaring operation is the outer doll. The cost of the next item depends on this complex relationship, and that's the puzzle we need to solve.
So here's the challenge and the fundamental concept we need to lock in. To get from a rate of change, like our marginal cost, to a total amount, like total cost, we have to integrate. It's the exact reverse of finding a derivative, right? If the derivative gives you the marginal rate, the integral brings you back to the total. But with a composite function like the one we have, we can't just use the simple power rule. We need a special technique to handle those nested parts of the equation.
And that special technique is integration by substitution, but you'll almost always hear it called U-sub. Honestly, it's one of the most important tools you'll learn in calculus, especially for business applications. So let's unlock this thing and see exactly how it works.
At its core, integration by substitution is really just a clever method for making our lives easier. It's a technique we use to simplify the integral of a composite function. The whole idea is to temporarily swap out that complex inner part of the function with a new, much simpler variable that we're going to call u. This process turns a problem that looks really difficult into one that's actually quite easy.
And the great thing about it is that the process is wonderfully systematic. It's like a recipe. We're going to follow these 5 steps exactly every time. First, we identify and choose our u. Second, we find its derivative, which we call du. Third, we rewrite the entire integral, but this time only using u and du. Fourth, we perform the integration, which should now be simple. And finally, and this is a step so many students forget, we have to substitute our original variable x back into the equation to get our final, meaningful answer.
Okay, theory is important, but practice is where the real learning happens. So let's apply these steps directly to our manager's dilemma and solve this thing together step by step.
All right, step 1, choose u. We need to look at our function and find the inner part, that piece that's nested inside another operation. In our function, we have the expression x squared plus 50 that's being raised to the second power. That makes it the perfect candidate for our u. So we're going to set u equal to x squared plus 50.
Now for step 2, we need to find du. So we take the derivative of our u with respect to x. Well, the derivative of x squared is 2x, and the derivative of a constant, 50, is just 0. So du by dx equals 2x. Now, if we just rearrange this a little bit, we get du equals 2x dx. And right here, this is the magic moment. Look at 2x dx. That is the exact other part of our original integral. This is the big clue that tells us we have chosen the right u. It works because u substitution is really just the chain rule in reverse.
And this is where you really see the power of this technique come to life. In step 3, we do the substitution. We're going to replace x squared plus 50 with our u, and we'll replace 2x dx with du. And just like that, our complicated, messy integral now becomes the incredibly simple integral of u squared du. We've turned a really tough problem into a basic one we already know how to solve.
So now we can just integrate. Using the power rule, the integral of u squared is simply u cubed over 3, and we always add c, the constant of integration. In a business context, this c is super important.
It often represents your fixed costs, things like rent or salaries that you have to pay even if you produce 0 units. But we are not done yet. The final, absolutely crucial step is to substitute x back in. We replace u with its original definition, x squared plus 50, to get our final total cost function in terms of x.
Okay, the process itself is pretty straightforward. But believe me, there are a couple of small mistakes that can lead to big errors. So let's go over a couple of these common pitfalls so you can avoid them in your own work.
The single most common mistake I see is choosing the wrong u. If you make the wrong choice, what happens is you'll get through step 2, find your du, and it just won't match the other parts of the integral. Your substitution doesn't actually simplify the problem. The key is to always look for that relationship. Choose the inner function whose derivative, or at least a multiple of it, is sitting right there next to it in the integral. The second major pitfall is just forgetting to substitute back at the end. It happens all the time. You finish the integration, you get the answer in terms of u, and you stop. But an answer left in terms of u is mathematically correct, but it's practically useless for our manager. Your manager asked for a cost function based on x units produced. You absolutely must complete that final step to translate your mathematical solution back into a business-relevant answer.
So, we did it. We have our total cost function. But in business, the math is really just the starting point. The real value comes from how a manager, how you, can use this information to make really important financial decisions.
You see, this total cost function becomes the bedrock of your financial strategy. With it, you can pinpoint the exact production level you need to hit to break even. You can set prices for a whole new batch of products with confidence, knowing your costs. It informs those multi-million-dollar decisions about whether or not it's time to scale up manufacturing. And of course, you can calculate the precise profit on any specific production run. This is exactly where calculus becomes capital.
So let's end with this one crucial point. The objective in business mathematics is never just about solving for a variable. The true goal is to take that solution and use it as a tool for insight, for strategy, and for making smarter, more profitable business decisions. Master this, and you're not just a student. You're on your way to becoming a future business leader.